And welcome to part 2. Let's solve this equation. 4 to the 4x equals 5 to the 7x plus 6. The reason this is difficult is our bases are not the same. If our bases were the same, we could take the log of both sides, bring down the exponents, and then the logs would cancel, which would be great. But they're not the same, so we either need to take the natural log or the regular log of both sides. So what's the difference, you might ask? What's the difference? The only difference of using regular logs versus natural logs is what you end up in your final result. Instead of getting natural logs here, you'd get another type of log, and then you just need to be careful of which button you type into your calculator. And so just for the sake of variety, I'll solve this one with logs of base 10, but it doesn't really make a difference. So take the log of both sides. Log base 10 of 4 to the 4x equals log base 5 to the 7x plus 6. Note that there was not any simplification I could have done to help me out before taking the log. Next, the 4x comes down, and the 7x plus 6 comes down, and you must put that in parentheses. You'll get this wrong if you don't put this in parentheses if there's more than one term in the exponent. Now it's just a matter of getting all of the x's to one side and solving. So to use the distributive property on the right, 4x log 4 equals 7x log 5 plus 6 log 5, like that. And then we want to subtract that 7x over. Anything with an x will move to the left. It's important that you realize that these are not like, well, they're not like terms, and so you shouldn't try to do 4x minus 7x is negative 3x because of the log 4 log 5. Your best bet is just to write it as 4x log 4 minus 7x log 5 equals 6 log 5. And with that, we're 2 steps away. Everything with an x we moved to the left, and so now we can factor that x out. So if we factor it out, we get 4 log 4 minus 7 log 5, and we did not do anything to the right side. And now you're 1 step away. Just divide both sides by, because remember, this is all just one number. In fact, maybe you even went ahead and plugged in the number into your calculator. I don't recommend you do that, but you could have. And we'll divide this side. This all cancels. So you get a final answer of x equals 6 log base 10 of 5 divided by 4 log base 10 of 4 minus 7 log base 10 of 5. So you notice that there's not really a difference in using a log base 10 versus a log base 9. Just make sure that when you do this, you hit the right button on your calculator based on if you used regular logs or natural logs. As I said, I think most mathematicians like to use ln. So if you want to be like a purist mathematician, I would use natural logs. Let's do a few more. This one's a little bit different. Again, we want to solve for x. Log base 2 of all of this equals 4. This problem's a little bit different than the ones we did on the previous page. On all of these problems, the x was in the exponent. It was 5 2 something, and 3 2 something, or 4 2 something. Here, we actually have a log in the equation. So what do? Well, there's 2 things you could do. You can take both sides of the equation to the power of 2. In other words, take 2 to both sides. 2 to this equals 2 to that. But perhaps better is to do this. Realize that this is a log. And so the way to rewrite this is to say, here's your base. This to this power equals this. 2 to the 4, because remember, here's your exponent if that's a log. 2 to the 4 equals x to the 3 minus 48. And what you notice is that's the same thing as if we had taken both of these to the power of 2, or 2 to the power of these. Because the 2 would cancel the log 2, and you'd get x to the 3 minus 48 equals 2 to the 4, which is exactly what we got by using the definition of the log. So hopefully you see that they're kind of related. All right, 2 to the 4 is 2, 4, 8, 16. So there we go. Subtract the 16 over. So minus 16 minus 16. And I believe that will be 64. Yep. So we have 0 equals x to the 3 minus 64, and now we can solve that. Hopefully you remembered how to factor a cube, which is what this is. It would be x minus 4, and then I believe it is x squared plus 4x plus 16. So again, if you didn't remember that a to the 3 minus b to the 3 is equal to a minus b times a squared plus ab plus b squared. So we learned that earlier. So we can see that one answer is 4, and we're going to get 2 complex answers out of this. Actually, is that true? B squared minus 4ac. 16 minus 4 times 1 times 16. Yeah, so that's going to be a negative number. So the discriminant of this is negative, so we're going to get 2 complex answers out of this. It doesn't really make sense to plug in a complex number into a log. I mean, you could certainly find these 2 answers by using the Pythagorean theorem, but I'm guessing that the homework is only going to be looking for real answers. So I have a feeling the only one you need to find is 4. But for the record, we could find these 2 by using the quadratic formula. Did I say quadratic formula? I think I might have said Pythagorean theorem. I mean quadratic formula. All right, how do we do this? Natural log of 3x plus 2 minus natural log of x equals natural log of 4. Now is when it's a good time to remember your log rules. Okay? If I have 2 logs that are being subtracted, I can rewrite it like this. Do you see that? It's the natural log of this divided by the natural log of this, all inside the argument, if it's subtracting. Okay? Now we take both sides of the equation and take e to that. You can do that. You can take all of this e to all of this and e to all of this. And the reason to do that is because these are inverse functions, they kind of cancel each other, and you get 3x plus 2 over x is equal to 4. Notice I didn't want to take this and do e on this, because if I do that, I have to do e to all of this and e to all of that. And there's no real way for me to very easily distribute e to that and e to that. So that's why it's important to try to make it so that you just have one natural log on the left and one natural log on the right. Then take e to the power of both sides. Then they cancel. All right, multiply both sides by x. So we get 3x plus 2 equals 4x. And then just subtract 3x. 2 equals x. And that's the answer. Phew, all right, I think we have time for 1 or 2 more. Actually, let's finish off this section. We can do it. Log of 3 of z equals 1. Oh my goodness gracious. Well, again, this is easy to do if you remember the definition of the log. What is this log saying? It's saying 3 to the power of this exponent equals all of this. Okay? It's just like a regular log. 3, the base, to the exponent equals the number in the argument. In other words, 3 to the 1 equals log 3 of z. Okay? 3 to the 1 equals the inside. Now we can do that again. 3 to the exponent equals that number. And we've worked our way to z. So 3 to the 3 equals z. So z equals 27. You can even check your answer on that one. The log base 3 of 27, that's equal to 3, and 3 to the 1 is 3. So 27 is a number that satisfies that equation. All right, last one, we have n equals k over ln z plus b. Solve for z. So here's what we want to solve for. I think the first thing to do is to get it out of the fraction. I wouldn't try to do any natural logs or powers right now. So I would multiply the entire equation by the natural log of z as my first step, just to get it out of the fraction. Sorry, I put that kind of far away. I put it right here. So we get n times the natural log of z, n times the natural log of z. They cancel here, so we get equals k plus b times the natural log of z. So all I did there was multiply by the natural log of z, and that's why it canceled the fraction out. You know what to do next. Take all the variables we want and put them to one side. So subtract b ln of z, subtract b ln of z. Going a little long, but we're almost done. So we get n times ln of z minus b times ln of z equals k. Now factor the natural log of z out. Do you see how both of these have a natural log of z? So let's factor that out, which will give us n minus b in parentheses equals k. So as you can see, we're slowly working to getting our z. Remember, this is the natural log only of z right there. Divide both sides by n minus b. Boop, boop. Which gives us the natural log of z is equal to k divided by n minus b. Now we're one step away. How do we get z out of a natural log? We have to do the inverse function of the natural log, which is to the power of e. So we take both sides, e to that power. E natural log of z is just equal to z, because they kind of cancel each other, because they're inverses. And on the other side, we get e to the k divided by n minus b. By the way, sometimes in books, they have a difficulty writing exponents. So just for your information, this is the same as writing z equals the letters exp, parenthesis, k over n minus b. These two mean the same thing. Sometimes you'll see exp because they don't want to do really small font for a really complicated exponent. So if you ever see exp and then parentheses, that means e to whatever is inside the parentheses. Can you hang out for one more minute? Let's do this last one. How much is needed for 37,000 to grow to 41,680.23 if deposited at 6% compounded quarterly? Hopefully you remember the compound interest formula, which I will write again for your convenience. P times 1 plus r over n to the nt. And let's solve this. So plug in what we know. We want 30, this is our final amount. This is what we grew into. So I write 41,680.23, substituting that for a, equals 37,000, which is our principal. That's our starting amount. It's 1 plus. Our interest rate is 6%, so you plug in 0.06 divided by, we're compounding quarterly. N is the number of times we compound a year, so that's 4. And 4 up here. And it needs to know how much time is needed, and so I actually don't know what t is. So we are going to solve this equation for t right there. Wow, okay, so let's do that. So what do you think is the first thing we should do? Let's start by just moving this 37,000 over. Divide both sides by 37,000. So I'm going to do that in my calculator. 41,680.23 divided by 37,000. So I get 1.12649 equals 1 plus 0.06 over 4 to the 4t. Okay, now there's not much more I can do with this because all this is glued together by the 4t up here. So that means now is the time to take a log. And it's your choice. You can either take a natural log or a regular log. I mean, when I say regular, I mean base 10. I'm going to use natural log. So take ln of both sides. So let's do the ln of this number, which is 0.1191 equals, the 4t can come down. So it's 4t times the natural log of 1 plus 0.06 divided by 4. So the 4t, because it's an exponent, came down in front like that. So now we can figure out what this number is. So let's do that. Let's do 0.06 divided by 4 plus 1. And then we're going to take the natural log of this. So I get an updated equation. Didn't do anything on the left. Still have 1191 over there. We have 4 times t times this number up here, because I just crunched all of this on my calculator and zapped it with the natural log and got 0.148886. Okay, let's times that by 4. 0.1191 equals 0.05955 times t. And then finally divide both sides by this number. So this last part was just some basic algebra steps. So let's do that. It's 0.1191 divided by 0.05955, which is just exactly 2. So it's going to take exactly 2 years. If you plugged in a 2 right here, 37,000 would grow to 41,680 and 23 cents. So you see how it's nice to be able to work these backwards, especially if you're a retirement planner. How much do you have to save now so that you can grow, or if you have this much, how long will it take to grow to this amount? So I know this video is a little longer than usual, but we are now done with 4.5. One section to go, 4.6, and I will see you there. If you have any questions, please leave them in the comments, and don't forget to like and subscribe. Thank you so much, and see you in 4.